increased, and no difference in the fatty acid component. However, PUFA, N3 and N6, PUFA by saturated fatty acid increased in all the treatments, including the nori diet and the diatom diet, that means ketocerous calcitron. So this experimental results indicated that ETN is a good candidate for a substitute to live diatom for culturing short-neck clam. My next experiment was the rearing of juvenile Japanese scallop by using single-cell pyropia in the recirculating aquaculture system. This is a preliminary trial, and before that no experiment have been done on this species. So about the Japan and the scallop, we can see this red line is the Japan production, and this whole bar is the total world production, including 5-6 countries. So it's showing that almost entire production comes from the Japan. This is the natural harvest, this is the aquaculture. Both of Japan is dominating, and this species also culturing in many other countries and transplanted to the France and Canada from the Japan. However, production of aquaculture is declining in Japan. As the production of decline in Japan, also world production declining because Japan is dominating for the species. And this species can only culture in the temperate sea, that is low temperature species. And off-bottom culture using the wild seed is the common practice. This technology developed by Japan long time ago, and microalgae is the main food for them. They are filtering from the ocean. This species can tolerate wide range of temperature from 1 degree centigrade to 31 degrees centigrade. However, 15 to 20 degrees is the optimum for their growth. No study was conducted on artificial diet on land-based aquaculture system for this species. That's why a preliminary study was designed for the rearing of Japanese scallop by using the single-cell pyropia. This is our experimental tank. I modified it from the Rispan. So the used water pump through the submersible pump to the protein schema, passed to the mechanical filter, then biological filter. And from here, water pump through the UV light, and this is the chiller system. And the fresh water or clean water passed to the tank again. The entire system was controlled by a digital thermocontroller system. So like as the short-neck clam, we used we mixed the feed with the seawater and provided to the scallop 3 times per day. After 2 hours of the last feeding, in a static condition, water supply was restarted to flush out the leftover feed. So this is the growth parameters of scallop experiment. Here we also found that significantly higher survival rate was obtained in the enzyme-treated diet compared to the other treatments, and a small difference was observed between in the carcass weight and carcass ratio, and no difference in the length, width, or depth or shell weight of the scallop. The approximate composition also showing that the higher percentage of protein was observed in the ETN diet compared to the natural diatom, and lipid level increased in all the treatments. We didn't find any significant difference of fatty acid. However, in the ETN diet, the total saturated fatty acid and monounsaturated fatty acid increased with the increasing level of nori. So this result showed that difference was observed in the survival rate and carcass ratio. Significantly higher protein level was observed in the nori treated diet, and enzyme-treated nori 1.5% had no negative effect on the growth and body composition of Japanese scallop. And this preliminary study showed that scallop filtering the Etienne diet successfully, and it can be used as artificial diet for culturing juvenile scallop. However, further research needs to be done on different formulation of this species and other nutrients as well. So now I would like to present another experiment on the supplemental effect of enzyme-treated nori on growth, feed utilization, and body composition of Japanese sea cucumber. All three species: Japanese scallop, Japanese sea cucumber, and Japanese short-neck clam. This one is the Japanese sea cucumber. This article accepted in the aquaculture research. This is also one of the important species in Japan, and it's distributed from the North Pacific 35° north to the Far East Russia Federation. These all are the cold or temperate region, and the demand of the species is increasing because of its nutritive value and medicinal value. It contains high protein and low lipid. Also, it has different types of bioactive compounds that make it valuable for the consumer. However, natural stock of this species is declining. So this picture is showing the total all sea cucumber in the world. If we divide the picture into two, we can see that the other sea cucumber production is increasing. This is the Japanese sea cucumber production is decreasing. So this is the landing from the Japan. This is the Korea. Japan and Korea, these two countries now the important countries for the landing. And in Japan, about 30% of the total harvest has declined. In Korea, 40% decline. In Russia, more than 80%, in some cases more than 95% decline. In China, some reports says no existence of sea cucumber in the China. So for this reason, IUCN calculated that more than 60% of the total world production declined. That's why IUCN declared is a red listed species and need to be conserved. For the conservation, we need to develop artificial feed, and we need to develop the commercial aquaculture in land-based system. In Japan, till now, no aquaculture practice is going on. However, Japan producing the seed and releasing to the ocean to increase the natural production. China started the aquaculture in the extensive way, and this picture is from the Russia trying for commercial aquaculture in intensive way, though the production is still very low, and they are trying to develop it. Bottleneck is the feed. Optimum nutritional requirement and low-cost balanced diet is bottleneck for the commercial aquaculture of this valuable species. Why this is valuable? From Hokkaido origin, the species 1 kilo dry product about $3,000 in the Chinese and Korean market. So microalgae and powder brown algae with sea mud are using as a component of formulated diet. The brown algae become expensive, and microalgae itself is costly. So our objective is to investigate the effect of dietary inclusion of single-cell pyropia on growth and biochemical composition of Japanese sea cucumber. These are some pictures of our feed. We use 10 gram per kilo of nori and 30 gram, 50 gram, and without nori diet as a control. So these are our experimental setup. We collected the species from the nature, acclimatized them for the 2 weeks, and maintained the temperature 15 degree. For this species, they are nocturnal, so we use for the period 16 hours dark condition and 8 hours light condition, and we conducted the experiment in the recirculating aquaculture system with dry sinking pellets. We used 2 individuals in each tank, and we collected the feces and eat and feed every day. and we provide them feed ad libitum. Every week we measure their growth. The research was conducted for the 6 weeks, and each treatment with 3 replication. So these are the combination of feed. We use 135% nori. The protein content of the feed was approximately similar, and they require very less amount of lipid, and we maintain 3% lipid. Normally they require 3 to 5%, not more than this. So the picture showing that our feed attract to this animal, and they consume our feed and eating and discharging the feces. These are the feces we can see, and this is the healthy sea cucumber. We can see by their sharp spike in the body. Some other pictures, when we provide the feed, they are moving to the feed, and after cleaning the tanks, they are moving, they are searching for the feed during the interval time. So we didn't see any competition between the species. They live together. Sometimes in 1 or 2 times we found some chemical mediator. If someone attacked to anybody, they secrete some chemical substance to prevent the others, and if we saw a very rare sometimes. However, no evisceration was observed during the treatment. The peculiarity of this species is that if there is any unfavorable condition or in any unfavorable situation, they discarded their intestine out of their body, and they remain kept in that position. However, they can regenerate their intestine. It will take time. So I would like to show you one video of feeding behavior of this species. Might be interesting to some of the students, as it is the new species, not very common for the experiment. So this is our experimental tank. These are the feces. We can identify the feces very easily, very sticky. And when they are searching food, they have the 20 tentacles around their body, and they open their tentacles and search for the food. This species is now searching for the food, and he is opening his tentacles gradually. Yeah, these are the tentacles. They can catch food by these tentacles, and they doesn't have any eye. They move by the sensory organ. So from the smell of the feed, they can move from one side to another side or one corner to the another corner. So he is searching for the food, but no food available in this corner, and he opened all his tentacles, flower-like tentacles. It's like a hand they can catch and put inside the mouth. As no food is available in this corner, he closed all of his tentacles. But let's see what he is doing now. Maybe a smell coming from the other side. This is the next morning when I come to clean the feed. There is some feed still remaining in another corner, and he is now checking the feed, whether these are feed or other items or the feces. But sometimes they also consume their own feces if no feed is available, but that is very rare. So he tested the feed particles. If it is tasty, he will start eating. Yes, he is catching the feed particles, and by catching this one, by catching feed particles, and he put inside his mouth. So after that, when I disturbed him, he stopped his feeding. So the research showed that mean weight gain of sea cucumber during the experiment increased with the increasing level of single cell particle, and we found that more than 5 kilogram of sea cucumber can be obtained by per cubic meter of water in the recirculating system. a specific growth rate, also showing the similar trend